kind of like yesterday, we've got a good variety of problems here. We're getting ready to take the final. We actually have a quiz tomorrow that's going to cover most of this stuff to just make sure that we know what we're doing. So let's just go ahead and start with the first one here where we have the square root of a equals 12. I'm going to start this the same way as I always do. I'm going to circle a variable and draw the line of equality. And what else do I need to do for this type of problem? We're going to box what? The square root, right? Anytime we have a square or a square root, we're going to put a box around it. And that box is a reminder that I need to get that square root by itself before I can get rid of the square root. All right, so is there anything I need to get rid of to get that square root by itself? The box is already by itself, right? So we don't have to get rid of anything, except now we need to get rid of the square root. How are we going to do that? Yeah, we're going to use the exponent, the square, right? So we're going to square both sides. On the left side, the square is going to cancel out with the square root, and that leaves a, right? And then on the right side, what do we get? 12 squared is 12 times 12? 144. And that's it. That's your final answer. This equation here is a little bit more complicated. We're still going to circle a variable and draw the line of equality. But we also need to put a box around what? The parentheses, because those parentheses are being squared, right? So remember, anytime we have a square or a square root, we're going to put a box around it to remind ourselves to get that by itself. Notice that the 3 over here is not inside of the box because it's not inside of the square. So that's the first thing I need to get rid of. How am I going to get rid of that 3? Divide by 3. So we divide by 3 on both sides. When the 3's cancel on the left, what's going to be left over there? Everything else, right? So we're going to have the 3b minus 7 squared. And on the right side, 75 divided by 3 is 25. All right, now we have the square by itself. There's nothing outside of the square anymore, so what do? We take the square root of both sides. That square root's going to cancel out with the square on the left side and leave what? 3b minus 7. And on the right side, the square root of 25 is the number that multiplies by itself to get 25, which is 5. Or? Yeah. So 5 times 5 is 25. That's why we get 5 here. But negative 5 times negative 5 is also 25. So we get another equation. Remember, anytime you have a square on a variable, which we have the square, when we started out, we had the square on the b, among other things. We're going to get 2 different equations, which means we get 2 different answers. So we have 3b minus 7 equals positive 5, and 3b minus 7 equals negative 5. What next?
Get rid of the negative 7.
Yeah, we're just going to solve like we normally do. So let's just continue with this equation over here. We'll get rid of the negative 7 by adding 7 on each side. On the left side, when the 7's cancel, the negative 7 with the positive 7, we get, on the left side, when the 7's cancel, we get 3b, right? And then on the right side, 5 plus 7 is 12, and then what? Divide by 3 on each side. When the 3's cancel on the left, what is that going to leave? B. And on the right side, 12 divided by 3 is 4. So that's one of your possible answers. But again, we have another one. We have another equation to solve, so let's do that one. What are we going to do first in the other equation? We're going to get rid of the negative 7. Same thing we did over here, right? So we're going to add 7 to both sides, but when we add 7 on the left side, we're adding it to a negative 5 instead of a positive 5. So what's negative 5 plus 7? 2. Okay. And then what? Divide by 3 on each side to get rid of the 3's. That leaves b on the left side. And on the right side, what's 2 divided by 3? 2/3. We're just going to leave it as a fraction. Can we reduce that fraction? No. So we can't do 2 divided by 3, so we're just going to leave it as a fraction 2 over 3, and there's your 2 answers. b equals 4 or b equals 2/3. And we could check these 2 answers by plugging them in up here for b and simplify each side and see if we get the same thing. When we circle the variables here, we notice that we've got more than one, right? We got c's and they're on both sides, so we need to simplify. What's the first thing we're going to do to simplify? we're going to distribute. So on the left side, we've got a 2 to distribute. 2 times 3c is 6c. 2 times negative 5 is negative 10. And then should I do 2 times c? No, we're not going to do that, so we're just going to bring that plus c down. On the other side, we can distribute this negative 8. Remember, it is a negative 8. So negative 8 times c is negative 8c, and negative 8 times negative 1 is
8.
Positive or negative? Positive. A negative times a negative gives us a positive. And then, again, the 12 didn't distribute, so we'll bring that down. After we distribute, we still need to simplify by combining like terms. On the left side, we've got like terms. 6c and c give us 7c, because that's a 1c, right? So 6c plus 1c is 7c. The negative 10 doesn't combine with anything, so we'll bring that down. On the other side, we bring down the negative 8c, since that doesn't combine with anything. And the 12 and the 8 combine to give us plus 20. All right, we got our equal sign on the line of equality. We've simplified both sides, but we still have c's on both sides, so we need to get rid of one of them. Which one do we want to get rid of?
8.
The negative 8c. Why? Yeah, we want to pick on the little one, and say that again, Jacob. Exactly. A negative is smaller than a positive. So we're going to get rid of the negative 8c because negative is always smaller than positive. All right, and how do we get rid of the negative 8c? We're going to add 8c to both sides. So we add 8c to each side. 8c's cancel on the right, leaving 20. On the left side, what's 7c plus 8c? 15c, and then bring down our minus 10. Now we've got the c in one place, so we just have to get rid of a couple things. What are we going to start with? Okay, we'll get rid of the minus 10 by adding 10. The 10s cancel on the left, leaving what? 15c. And then on the right side, 20 plus 10 is 30. All right, then what? Divide by 15 on each side. 15s cancel, leaving c, and 30 divided by 15 is 2. Moving on. I know I've mentioned this before. This is actually an equation that you might see in a geometry class when you're doing stuff with what's called a right triangle, a triangle that has a right angle in it. You can use a Pythagorean theorem and you get equations that look like this. So we want to solve for d. We're going to try to get d by itself. I do need to put a box around my square. Do I need to put boxes around all 3 squares here?
No.
Which one do I want? Just the one with the d, right? So that's the square I have to get by itself. The other squares I can actually simplify. How could I simplify the 6 squared here?
36.
Yeah, it's just 36. It's 6 times 6, which is 36. And what would I get for the 4 squared? 16. Can I do d squared like that? Can I simplify that?
No.
No. We don't know what d squared is yet because we don't know what d is yet. So we have to leave that d squared there. All right, now I still need to get the square by itself. That's why I boxed it here. So I need to get rid of the 16 by doing what? Subtract 16 on each side. 16s cancel on the right, leaving what? On the right side? D squared. And on the left side, 36 minus 16 is 20. Then what? We have to get rid of the square, right? How do we do that?
Square root.
We're going to take the square root, exactly. On the right side, the square and the square root cancel, leaving d. On the left side, what's the square root of 20?
2.
It's not 10, because 10 times 10 isn't 20, right? It's not 5, because 5 times 5 isn't 20. So it's not a perfect square. So what are we going to have to do with it? We're going to have to simplify it. So we're going to do a factor tree. Yeah, we need the factor tree, so we're going to factor 20. We get 2, 2, and 5, and then what do we do with those factors?
Extended form.
Here.
2 times 2.
We need to rewrite it. So we write the square root of 20 as the square root of 2 times 2 times 5, and then circle of pairs, and the pairs go outside, and 5 stays on the inside. So we get 2 square root of 5 there. That means that 2 square root of 5 times 2 square root of 5 is the square root is 20, not the square root of 20, but just 20. So that's my answer, right? Is that my only answer?
No.
No. What else could multiply by itself to get 20 besides positive 2 square root of 5 times positive 2 square root of 5? Negative 2 square root of 5 times negative 2 square root of 5 would also give us 20, right? So both of these answers work because I could square this or multiply it by itself to get 20, and I could square this or multiply it by itself to get 20. All right, so either one is going to work. Does anybody know the shortcut to writing the positive or the negative of the same number? Shira? If you get an answer that is the same answer, just one's positive and one's negative, which actually doesn't happen that often, but it did here. We got positive 2 square root of 5 and negative 2 square root of 5. You could write it like this, and this means both answers at the same time. Just save you a little bit of writing if you want to do that. This is probably a better way to do it so that we don't forget or we don't try to start using this when we're not supposed to. So that's just an option for you when you get the same answer, just one's positive, one's negative. Okay, moving on. This last one here we do not need to solve. Walking around, I saw a lot of people were drawing the line of equality on this equation. They were circling the variables. They were trying to use the golden rule to get the x by itself. We don't want to do that. We've already solved it, and we've gotten two different answers. And I will tell you, if you solve this equation right here, we don't know how to do it, but if you did know how to do it, and you solved it, you would get both of these as your answer. So we just want to check now to make sure that they both actually work. So how do I check just the 10 right now? Forget about the 17. How do I check to see if 10 is an answer or a solution for this equation? We are going to substitute the 10 anywhere that we see an x. So we're going to go up to this equation here. We're going to rewrite this equation. And anywhere I see an x, I'm going to put a 10. Now I'm going to write it over here off to the side because we're going to have to do it again with the 17. All right, so I'm going to write that equation exactly like it is, except I put 10s where the x's are. Now notice that I put the 10s in parentheses. Why would I do that?
So you can know to multiply.
Yeah, so we know it's multiplication. If I didn't put it in parentheses, this right here would look like 310 instead of 3 times 10, right? So we want to put it in parentheses when we're plugging it in. It really wouldn't be necessary here, because if we take the parentheses off, it's still 10 minus 1 inside of the square root. But we do need it here. Now, once we do that, once we substitute, what are we going to do next? What we want to do at this point is simplify the left side, simplify the right side, and see if we get the same thing on both sides. So since I want to keep the left side and the right side separate, I'm going to draw this line. It's the same as the line of equality, but it has a different purpose for us now. This time when we draw this line, it's going to keep our left side separate from the right side. It's not a reminder that whatever we do on one side, we have to do on the other, because we're not doing that. All right, we're just going to simplify. So looking at the left side, what's the first thing I'm going to simplify? Am I going to do 3 times 10? Am I going to do 10 minus 1? Am I going to do negative 1 plus 18? Am I going to take the square root of 10?
3 times 10.
So we can't do 3 times 10 because 10's in the square root and 3 is not. Can we just simplify what's inside the square root? Can we do the 10 minus 1? Yeah. And notice, this is really important. Notice that the minus 1 here is inside the square root and the plus 18 is outside the square root. It's really important that you write it that way when you rewrite the equation. The 1 needs to be inside and the 18 outside. So we'll simplify what's inside of the square root, the 10 minus 1, which is, what's 10 minus 1? 9. And then we were going to bring everything else down. So all we did is we did the 10 minus 1, put down the 9 there, but that's still inside the square root, so everything else looks the same. Are we going to do 3 times 9? Are we going to do 9 plus 18? Are we going to do the square root of 9? We need to take care of that square root next. A square root, when we're doing order of operations, a square root is actually the same thing as an exponent. So after we do what's in parentheses, which this 10 minus 1, even though there's not parentheses there, that's doing what's in parentheses because that's inside the square root. Now we need to actually take care of the square root. What is the square root of 9? 3. So we're going to bring that 3 down and then bring down everything else. Now that looks like a 33, but I don't think it's supposed to be a 33, is it? Yeah, it's actually 3 times 3. So to do that, we're going to put that as second 3 in parentheses, just to remember it's multiplication and not just a 33. Okay, we still need to keep going with order of operations, so we are either going to multiply or add. Which one do we do? We're going to multiply. 3 times 3 is 9, and and then bring down our plus 18. And then there's only one thing left. 9 plus 18 is 27. So we're done simplifying the left side. We've simplified everything using order of operations. We get 27. On the right side, we need to use order of operations there. This one's going to be a little easier. Are we going to multiply or subtract first? Multiply. So we do 3 times 10 and get 30. Bring down our minus 21, and then 30 minus 21 is 9. What does that mean?
It's wrong.
It's wrong. We got 27 on the left, we got 9 on the right, we got 2 different answers, so 10 is an incorrect answer. All right, it's not a solution to this equation. Like I said earlier, if you solve this equation, you would actually get 10 as one of your answers, but it's what we call an extraneous solution. It's an extra solution that doesn't work. That happens sometimes. Moving over to the 17 here, what am I going to do to check 17? Same thing, right? So we're gonna do the same thing we did here, except we're gonna plug 17 in where the x's are. So we're gonna get an equation that looks like this. I want you to go ahead and finish that one up on your own if you haven't already. All right, so we're gonna split the left side and the right side up. Let's focus on the left side first. What's the first thing we're gonna do? Same thing as the first thing we did over here. Instead of 10 minus 1, we're going to do 17 minus 1, and we get 16, and then bring everything else down. Then we're going to do the square root of 16, and we get
3 times
4, and then bring everything else down. And instead of 34, we'll put that 4 in parentheses, so it's 3 times 4. Then we're going to multiply. 3 times 4 is 12, plus 18 is 30. Then on the right side, we'll do 3 times 17, get 51, minus 21, and 51 minus 21 is 30. So what does that mean?
correct.
It is a correct solution. So 17 does work for x here. All right, 10 did not work, but 17 did.